We'll now look at trig integrals. So for example, let's try to evaluate sine to the 5th power of x dx. So far we have no way to do this. However, I'm basically going to rewrite this problem. I'll rewrite this as sine to the 4th x times sine x dx. And it may not be immediately obvious why I want to do this, but we'll get there. Now, sine to the 4th x is sine squared. So I'm going to use this identity that sine squared is the same thing as 1 minus cosine squared times sine x dx. And the reason I want to do this is because I do know how to do problems where I let u be equal to cosine x, and then du would be equal to negative sine x dx. So now this turns into negative the integral of 1 minus u squared du, which we do know how to solve. We'll start by multiplying this out to get 1 minus 2 u squared plus u to the 4th du. So when we integrate this, we have negative u minus 2 over 3 u cubed plus 1 over 5 u to the 5th plus c. Substituting back in and distributing the negative sign gives me the answer of minus cosine x plus 2/3 cosine cubed x plus 1/5 cosine to the 5th x plus c. Now let's try the integral of cosine to the 4th. If I try to use the property that I used last time, I'm going to run into an issue, because then I'll have cosine cubed times cosine, and I won't have a way to turn every single one of those cosine cubes into a sine function. For that, I would need a remaining even power of cosine after I split one off. So here I'm going to use a different identity. In particular, one that says that cosine squared x is 1/2 1 plus cosine 2x. So that means I can rewrite this integral as 1/2 times 1 plus cosine 2x squared, since we do have this raised to the 4th power. So 1/2 squared is 1/4, and then I have 1 plus 2 cosine 2x plus cosine squared to the 2x dx. So this is 1/4 times the integral of 1 plus 2 cosine 2x. And I don't quite know how to deal with this either. So I'm going to use this same property again and write this as 1/2 1 plus cosine, and this time I'll have to the 4x dx. And now I can integrate. So this is 1/4 times the integral of 1 is x, the integral of 2 cosine 2x. So the integral of cosine would be sine, and then I would have to divide by a 2. So I would just get sine 2x. Plus 1/2 times the integral of 1 is x, and the integral of cosine to the 4th would be 1/4 cosine 4x plus c. Simplifying this a little bit, I have 1 over 4x plus 1 over 4 sine 2x plus 1 over 8x plus 1 over 32 cosine of 4c. Or sine, sorry, this should be a sine, since the integral of cosine is sine. So some strategies for sine and cosine. If I try to integrate the integral of sine to the m power times cosine to the n dx, well, if the power of sine is even, then I should split off a sine x and write the resulting even power of sine x in terms of cosine x, and then use the substitution u equal to cosine x. So this is what I did in my first example. If n is odd, so the power of cosine is odd, I'll split off cosine x and write the resulting even powers of cosine x in terms of sine x, and then use u equal to sine x. So I'll do the same thing I did with sine. And if both of them are even, I can use half-angle identities to transform the integrand into a polynomial cosine 2x, and we'll keep doing this strategy once again until the powers of cosine of 2x greater than 1. You'll notice if the integrals of sine and cosine are both to odd powers, you can actually pick which one of these two strategies you want to use. So let's try this here. On this particular problem, sine and cosine are both even powers, so we're going to have to use our last strategy. So I'm going to have to rewrite this. I'll rewrite this first one as 1/2 1 plus cosine 2x squared. And then sine squared can be rewritten as 1/2 1 minus cosine 2x dx. So I'm going to go ahead and pull out, this is a 1/4 and a 1/2, so 1/8. When I square this term, I get 1 plus 2 cosine 2x plus cosine squared 2x times 1 minus cosine 2x dx. Once we multiply these terms out, I get 1/8 times the integral of 1 plus 2 cosine 2x, plus cosine 2x minus cosine squared 2x minus cosine cubed 2x dx. This is 1/8 times. The integral of 1 is x. The integral of cosine is sine, so I have plus. Since I have cosine 2x, the integral would be 1/2 sine 2x minus the integral of cosine squared 2x dx minus the integral of cosine cubed 2x dx. So these two integrals will be a little bit more complicated to deal with. So we'll start. The first one is an even power. So I'll rewrite this as 1/2 1 plus cosine 4x dx minus, this is an odd power, so I'm going to rewrite this as cosine cubed 2x, or cosine squared 2x times cosine 2x dx. I'm now going to let u be equal to cosine 2x